Operating system. Welcome to week 1. In this week, we are going to learn about the basics of operating system. This is Dr. Elizer. Objective of this particular week 1 is to learn about operating system objectives, functions, role of operating system, evolution of operating system, OS structure, major achievements of operating system. What is an operating system? Operating systems are programs that interface between the machine and the application program, or it interface between the hardware and the application program. So it's act as a interface between hardware and the software. So operating system is a program that controls the execution of application program. The main objective of operating systems. 1. Convenience. Easy to use. The second objective, efficiency. So the resource manager is one of the major objective of operating system. Third, ability to evolve. Permit effective development, testing, introduction of new system functions without interfering with service. Operating system functions. So here there are many operating system functions are listed. The first one is the program development, program execution, I/O device access, controlled access to files, system access, error detection and response, accounting. These are various functions of operating system. We'll learn one by one. Operating system function, the first one, memory management. It allocates and deallocates the memory. Keeps a record of which part of primary memory is used by whom and how much. Process management, it allocates and deallocates processor to processes. Keep record of CPU status, whether the CPU is ideal or not, and so on. The third one, device management. It deallocate devices to different processes whenever needed. It keep records of all the devices. It decide which process use which device, how long to use the device, and so on. Fourth one, file system management. It keeps records of status and location of files. So allocation, deallocation of files to the processor. It decides who gets the resources. It means who get the file system for the particular process. The fifth one, storage management. It improves the performance of data storage resources. It optimizes the use of various storage devices. It assists business in storing more data on existing hardware, speeding up data retrieval process, preventing data loss, meeting data retention regulation, and lowering IT cost. These are various operating system functions. Now we'll discuss about the services provided by operating system. What are the services provided by operating system? There are 12 services listed here. Program execution is a service. So operating system executes the programs. It performs input-output operations. What do you mean by input-output operation? It gets the data from input device. Similarly, it displays the data into the output device or send the data to the printer like output device. Communication between process. So when multiple processes execute at the same time, operating system communicates between the process. Fourth, the file management. It manages the files and it manages the memory, how much memory is reserved for a particular process, and so on. And process management. So if more processes try to execute at the same time, it will schedule the process. So the process management is one of the service provided by OS. Security and privacy, data security, privacy. So that and all service. Resource management, all the devices are, all the resources like CPU is a resource, device is a resource. The resources are managed by the operating system. User interface. Operating system only acts as an interface between the user and the program, or between the interaction between the user and the hardware. Networking is another operating system service. Error handling. If error comes, how to manage the errors, and time management. These are the 12 services provided by OS. Now we will verify our learnings. Operating system acts as an dash between hardware and application program. Controller, utilizer, interpreter, or interface. Operating system acts as an interface. The answer is D. Interface. The second question, which of the following is a function of operating system? Database management? No. Compilation? No. Process management? Yes. So process management is the one of the function of operating system. Software management is not. So the answer is C. Process management. Next topic that we are going to discuss is role of an operating system. The operating system has three roles. It acts as an interface between the user and computer. So interface. Second role is resource management. Third role is operating system act as a software. Okay. So computer interface, resource management and software. We'll discuss one by one. The first role. The operating system is a user or computer interface. Computer hardware and software structure, layered organization, OS service to the users. So here you see the diagram. Here operating system acts as an interface between So this is an operating system act as an interface between the application program and hardware. The second role, resource manager. So operating system only allocates resources to all the process. This operating system is responsible for managing these resources. Operating system exercises its control through software. The third role, operating system acts as a software. So software means it performs functions of various things, programs, frequently relinquishes control and depends on the processor to allow the region control. So act as a software. Resource management, how it performs resource management? Whenever the operating system or whenever the process needs some resources, it allocate that resources and deallocate that resources. Now we'll verify our learnings. Which of the following is not a role of OS? Network filter, resource management, system software, user interface. The odd one is A, network filter. So that is not a role of operating system. Second question, which of the following resource is not managed by operating system? Which of the following resource is not managed by OS? Mouse, natural gas, keyboard, memory. Among these four, mouse, keyboard, memory are devices managed by OS, whereas natural gas is not. That is the odd one. So the answer is B, natural gas. Next topic that we are going to learn is about the evolution of an operating system. So how the operating system evoluted from the starting to the current era. So first start with the serial processing, then batch processing, then multi-programming, and then time sharing. This is the evolution of an operating system. We'll discuss one by one from the starting. Serial processing. What is serial processing? In serial processing before 1970, there is no operating system at all. Programmer interacted directly with the hardware. Inputs are given to the devices using card readers, and the errors will be rectified by the programmer manually. Then the corrected punch cards or card reader will be again given to the program. So no operating system at all. When one program executed by the system, no other programs can be executed. That's why it is called a serial processing, one after the another. So these systems have two problems. One, scheduling. So there is no parallel thing. So if one program takes 2 days or 30 minutes, all the other program has to wait. Second, setup time. Single job or single program need to load the compiler and source program to the memory. The second evolution of operating system is simple batch system. So here operating system execute jobs in batches. Job 1, batch. Job 2, so batch wise execution. User submits jobs to the operator as a batch. So batch system can see in two views. So monitor point of view, processor point of view. What is batch processing in monitor point of view? Control sequence of events partially resides in memory. Usually we call it as resident memory. Whereas in processor point of view, current batch programs executed in main memory. On completion brings next batch get loaded into the portion of user area. In monitor point of view, it reads a job at once and loaded into the program area, control passed to the user job. In processor point of view, once loaded, job gains control and execute the instructions. In monitor point of view, once completed, user program transfers the control to the monitor. Here, this continues until end of the program or error. Monitor starts to read next batch. Its results are sent to the output device in monitor point of view. In processor point of view, processor gains control means processor executes the current program instructions. So simple batch system works in this way. You see this diagram. Here we have a monitor performs scheduling of batches and improves job setup time. So we have a language called JCL, special type of programming language used to provide instruction to the monitor. So this program will be given to the compiler. So what compiler to use, then what data to use. So the program instructions are given to the monitor using a special language called JCL. For example, program is written in Fortran and other languages. Data is fed into a separate card in addition to this job is described using JCL. The input instruction read a line of data and invoke data routine, which is a part of OS. The user programs makes sure that it does not call JCL instead. At compilation time, monitor scan input line until next JCL instruction to make sure there is no too large or too low data lines. There are two modes of simple batch systems, user mode, kernel mode. In user mode, program executes in user mode. Certain area of memories are protected from user access. Certain instructions may not be executed in user mode, whereas in kernel mode it's like admin mode. Monitor executes in kernel mode. Privileged instruction may be executed. Protected area of memory may be accessed. So user mode, kernel mode are the two modes in simple batch system. Simple batch system overhead. Processor time alternates between execution of user program and execution of monitor. So sacrifice some main memory is now given over to the monitor. Some processor time is consumed by the monitor. Despite overhead, the simple batch system improves utilization of the computer. Multi-programmed batch system. That's the next evolution of OS. In batch processing system, memory holds resident monitor and one user program. Batch processing holds processor on idle when IO operations are being done. If memory is sufficient large to hold more than one program, then while one program is getting IO, processor can switch to another program that is called multi-programming. Are you able to understand? If in batch processing system, when one program is executes, other program or input-output operations cannot be performed. But in multi-programming system, when one program is executed by the CPU, the IO operations can be performed at the same time. So multi-job is executed here. That's why multitasking or multi-program. So this diagram clearly shows you. So it runs, then wait, then runs, then wait. This is in uniprogram, the previous concept. In multi-program, it will execute in this way. Here you see there are two examples given for multi-programming. Here program A, program B. When program A wait for some input-output operations, program B gets executed. So overall, the CPU is not idle. That is in a single batch processing system, CPU will be idle when one program is executing or the program wait for input-output operation to complete. The last evolution, that is time sharing operating system. In 1960, programs need dedicated computers, which was not possible as it was too costly in those days. Application much more user interactions need dedicated computers. Multi-programming designed to handle multiple interactive jobs as time slicing. User to share processor among multiple users and makes each user to feel that they have dedicated system but integrated among all of them. Hence, if n user is using, then each user see 1 by n of effective computer capacity. So what's the difference between batch multiprogramming and time sharing? Batch multiprogramming, maximum processor use. Whereas time sharing, minimum response time. Batch processing, job control language is used. Whereas in time sharing, commands ended at the terminal. So there are some different terms we have to understand clearly. Multiprogramming, keeping multiple programs in main memory at the same time. Multiprocessing, a computer using more than one CPU at a time. That is multiprocessing by multiple processor. Multiprogramming means multiple program by one processor. Multitasking is nothing but multiprogramming with round robin scheduling like that. Multi-threading is an execution of multitasking. So compatible time sharing system, CTSS. So we'll discuss about CTSS. CTSS is one of the first time sharing operating system developed by MIT by the group of Project Mac. It ran on a computer with 32,036-bit words of main memory with a resident monitor consuming 5,000 of that. To simplify both the monitor and memory management of a program, was always loaded to start at the location of 5,000th word. So this is compared with the time slicing. Time slicing system clocks generates interrupts at the rate of approximately 1 every 0.2 seconds. At each interrupts, OS regained control and could assign processor to another. So old user programs and data were written out to disk. Old user programs, code and data were restored in main memory when that program was next given at. We'll understand, verify our learnings. Keeping multiple programs in main memory at the same time, ready for execution is called a dash. Multiple programs in the memory at the same time, ready for execution. Batch processing, simultaneous processing, or multi-threading, or multiprogramming. The answer is multiprogramming. Second question, which of the following system has minimum response time? Multiprogramming, time sharing, multitasking, or multi-processing? The answer is time sharing. That is, has a minimum response time. Now we'll discuss about OS structure. Symbol structure. MS-DOS is the symbol structure. It has only 4 layers. Application program, resident system program, MS as device driver, and BIOS. That's all. And traditional Unix structure has a different layer. Here we have a kernel. Kernel system call interface to the kernel and kernel interface to the hardware. There are mainly 3 layers. One is the above the system call interface and kernel, below the kernel, that is hardware. This is the 3 layer. Unix limited by hardware functionality, the original. So cell programs, commands, everything will be executed above system call in. So interface. And kernel executes all the operating system routines. And finally, devices. Layered approach. So this is a layered approach. Layer 0, usually in Linux, the layer 0 represents the hardware. Layer 1 is the operating system. Layer 2 is the shell or command interpret and so on. Microkernel system structure. So moves as much from kernel to user space. Communication takes place between user modes using message passing. Easier to extend microkernel. Easier to port the operating system to new architecture. More reliable, more secure. Modules. Most modern operating system implement kernel modules. So user object oriented approach. These are say various Solaris kernel modules. So each and every modules are executed for their purpose. For example, module file system will execute only file system related programs and so on. Hybrid system. This hybrid system combines both architectures. So for example, here Mac OS uses a structure. Mac OS and Android, Google Android, iOS. So they uses hybrid structures. They are not simply uses either the modules or the microkernels or the layered approach. So they use a combination of the structures. That's why it is called hybrid systems. we'll check our understanding. Which of the following is the heart of operating system structure? Kernel, shell, hardware, or application? Kernel is the heart of the operating system. Second question, in which structure the communication between user and kernel is happening through IPC? Which structure communication between user and kernel is happening through IPC? Monolithic, microkernel, or layered approach? Microkernel. So the next topics, major achievements in operating system. There are 4 major advancements in operating system: process, memory management, information protection 60, scheduling, and resource management. The process. So the process is a systematic way of monitoring and controlling the program execution. The process is an executable program associated with the data and some information. So this is a simple implementation of a process. See here, we have many processes. They are executed by the CPU. So the process will be loaded into the PC and they executed. So process A, process B, and so on. Memory management. So that is the next key contribution. That is virtual memory. It allows the program to address memory from local point of view without regard to the amount that is physically available. Information protection security. So the protection and security is the next advancement in OS. Availability, confidentiality, data integrity, authenticity. These are various categories of information protection security. And the next one, advancement in OS is scheduling and resource management. Schedule the process, CPU process, or schedule the device process, and so on. And resource management, differential, responsive, fairness, effectiveness. So resources are allocated to the operating system in an effective way. Let's examine our learnings. What is a process? What is process in operating system? Program in execution, action by user, procedure to start OS, it is an application. Program in execution is the answer. Second, DAS is a facility that allows program to address memory from a logical point of view without regard to the amount of main memory physical level. The answer is virtual memory is a facility that allows programs to address memory from a logical point of view. Virtual means logical point of view. So in this week, we learned about OS objectives and functions, role of OS, evolution of OS, OS structure, major achievements of OS. Thank you.